Hey everyone, I hope you're doing well. This is Mike from PyroDelta Energy. Thank you for joining me today. Today I wanted to introduce to you the 100-watt module that we recently started building. And this is a demo unit that shows the core of 100-watt module and how it looks like from the inside. Of course, the ones that are going to be shipped to our clients will be packaged in a stainless steel packaging. So none of this will be visible, but I thought I would put one in display just to show you the ins and out. It is very important for us to distinct ourselves as an industrial provider. We are not providing novelty items. This is a 100-watt continuous duty module that utilizes the waste heat from sewage, from hot oil, or potentially the fluid from your car engine to generate meaningful energy that could be used on board a moving vehicle or maybe installed in a residential setting under the sink. So you can utilize the hot water being wasted from your sink and extract some of this waste heat to convert it into usable energy. Here in this setting, I chose the load of a very popular item. This is 4 strips of white LED that's usually being installed under the cabinets of kitchens. And the reason I chose this because if you installed one of those under your sink and utilize the waste heat from your dishwashing operation or just the general use of hot water, it will generate enough energy to keep your light on 24/7 without the need for any external source of energy. As you can see, this is a compact unit that could fit anywhere under a household sink with no problems whatsoever. So solar panels cannot compete with this size-wise. We are in the business of making thermoelectric modules industrial, practical. We are not here to fight for 1% efficiency here or there. We want to make these devices meaningful and usable and practical. So without further ado, very simple here. We have 2 thermometers. One is attached to the front plate, and the other one is attached to the back plate. So basically, all our modules come with 2 probes, one monitoring the front plate, which is the hot plate, and the other one is in the back and monitoring the heat from the back. This entire module will be enclosed and submerged in fluids. So hot water and cold water will be passing, touching these surfaces. And there will be an onboard small computer that will determine basically where is the water is directed. So if the water is hot water, will be directed to the front plate here, which is the hot plate. And lower temperature water will be directed to the back. So this way, we always maintain the heat differential between the front and the back, and this is how we generate energy. It's very important to make it clear, this is not an energy storage device. This is not a battery. This is an energy generating device. This is a thermoelectric generating device. And it's very important to differentiate that, when people talk about thermoelectric generators, they think about these small modules that are being sold, but this is not the case at all. We develop our own modules. As you can see this size comparison here, our modules are 4 inches by 4 inches, and they are sandwiched between these 2 plates. Here in the back here, we have a heat sink, and in the front is a spreader plate that spreads the heat. This will be enclosed, like I mentioned, in a stainless steel packaging, and there will be hot pipes moving all around it that will utilize the hot water from your sink or sewage or hot oil, depending on your application. And the other side will be cooled actively by either fans, or if you want to cool it by fluid as well, or maybe if it's submerged in ice or anything that will keep the temperature differential. So for this demonstration, we have our probes connected, and I'm going to use this heat torch, this torch right here, to show you how easy it is to generate about 10 watts to power these LEDs, but it is fully capable of utilizing the entire surface. Again, this does not do it justice because this heat is just concentrated in one spot and the heat should be distributed all over this hot plate, but this is just for demonstration purposes. So let's start it and see how fast it will generate electricity. So now the 4 strips started to light. Let me turn off the light and show you the effect. So I turned off the light, and now you can see the 4 strips are being lit. And just by a change of 10 degrees, as you can see here, we have 91.4 at the front plate, and at the back plate, it's 82. So a difference of 11 to 12 degrees is enough to power these modules here, these LEDs. That's more than enough to light under your cabinet, your kitchen cabinet. Just by a small heat differential, we're able to generate enough energy to power these LEDs, as well as the ability to be able to power a couple of devices, let's say an iPhone and an iPad, very easily. So let's try this test again. I'm going to turn on the light and I'm going to attach my multimeter to show you the power output by just a small heat differential. So just to give you an idea with numbers and actual measurements, I hooked up my multimeter directly to the module. Like I mentioned before, the module has a built-in voltage regulator. And here we have the temperature of the front plate and the back plate. The front plate is currently at 87.2 and the back plate is 85.2, which is 3 degrees difference of the temperature between the front and the back. And that's why we're generating 0 right now. And we will apply some heat to the front plate here. And we will see as the difference between the front and the back increases, we will be able to generate voltage. Let's see how much temperature do we really need to start generating meaningful voltage that we can use to power appliances. Immediately, we started generating about 10 volts, 9.96, almost 10 volts here. Very steady. And even when I remove the heat source, the residual heat that's on the front plate still produces enough energy here. As you can see, we're still generating 10 volts. The idea behind this is that it's small, it's compact, it can be installed anywhere. It doesn't have any moving parts or requires any maintenance for years and years, and it can generate enough energy to power small devices. We are building a 1 kilowatt hour module, and I'm expecting this module, when installed in a residential setting, to generate about 500 or 600 watts per day. As you turn on your dishwasher or dryer or any other appliances and you have this waste heat, these modules can sit in the back quietly doing its job, providing good amount of power without any maintenance required. Thank you very much for watching and joining me for this fun experiment. And if you have any questions, please reach out and I'll see you in the next one.